Hi guys, Arindam here, and in the fifth part of my museum video series, I will be taking a look at all the fishes present in the Ark Survival Evolved game. So let us begin. So I have color coded the floor to be navy blue, which will be the color of all the deep oceans and other places. The borders are colored with light blue or cyan to represent all the shallow seas and rivers and streams which are found for all river-like fishes. Okay. First we come to the anglerfish. Now the anglerfish is a fish of the teleost order Lophiformes. It is a bony fish named for its characteristic mode of predation, in which a fleshy growth from the fish's head, a fleshy growth from the fish's head called the esca or elysium acts as a lure for other fish. Anglerfish occur worldwide. Some are pelagic, that is, dwelling away from the seafloor, while others are benthic, dwelling close to the seafloor. Some live in the deep sea, while others are living on the continental shelf. Now, they range in color from dark grey to dark brown. Deep sea fishes have large heads that bear enormous crescent-shaped mouths full of long fang-like teeth angled inward for efficient prey grabbing. Their length can vary from 2 to 18 centimeters, with a few types getting as large as 100 centimeters. But this variation is largely due to sexual dimorphism, with females being much larger than males. Most of the adult female anglerfish have a luminescent organ called the esca at the tip of the modified dorsal ray, the elysium or the fishing rod. The organ has been hypothesized to serve the obvious purpose of luring prey in dark deep sea environments, but also serves to call the male's attention to the females to facilitate mating. What is interesting is the source of luminescence is from the symbiotic bacteria that dwell in and around the esca, enclosed in a cup-shaped reflector containing crystals, probably consisting of guanine. This light gland is always open to the exterior, so it is possible that the fish acquires the bacteria from the seawater. And by the way, anglerfish were never this big, and you definitely cannot ride an anglerfish. So yeah, that's that. Next we come to one of the most important fish to have ever existed, the coelacanth. Yes, it's very important. It may be trivial in the game, but it's very important in real life. So the coelacanth constitute a now rare order of fish that includes two extant species in the genus Latimeria. The West Indian Ocean coelacanth called Latimeria chalamnae, primarily found near the Comoro Islands of the east coast of Africa, and the Indonesian coelacanth Latimeria menadoensis. Coelacanths were thought to have become extinct in the late Cretaceous around 66 million years ago, but were rediscovered in 1938 off the coast of South Africa. Yeah, I remember the headline because I saw a picture of the newspaper clipping. That was several years ago, by the way. So, the coelacanth is considered a living fossil because scientists thought it was the sole remaining member of a taxon otherwise known only from fossils, with no close relatives alive, and that it evolved into roughly its current form approximately 400 million years ago. They started appearing from the early Devonian to the recent, that is, they started appearing from 409 million years ago to this current form. They are great survivors actually. Coelacanths are large, plump, lobe-finned fish that can grow to more than 2 meters, that is 6 feet 6 inches, and weigh around 90 kilograms or 200 pounds. They are estimated to live for 60 years or more. Modern coelacanths appear larger than those found as fossils. Coelacanths are fairly peaceful when encountering others of their kind, remaining calm even in a crowded cave. They do avoid body contact, however, withdrawing immediately if contact occurs. When approached by a foreign potential predator, they show panic flight reactions, suggesting that coelacanths are most likely prey to large deepwater predators. Next we have is the Dunkleosteus. Dunkleosteus is an extinct genus of placoderm fish that existed during the late Devonian period about 358 to 382 million years ago. It consists of 10 species, some of which are among the largest placoderm fishes to have ever lived. The largest species, Dunkleosteus terrelli, grew up to 8.79 meters or around 29 feet long and 4 tons in weight. Dunkleosteus could quickly open and close its jaw like modern day suction feeders and had a bite force of 6,000 newtons, which by my estimate is around half of that of a saltwater crocodile at the tip and around 7,400 newtons at the blade edge. Numerous fossils of the various species have been found in North America, Poland, Belgium and Morocco. Like other placoderms, Dunkleosteus had a two-part bony armored exterior, which may have made it a relatively slow but powerful swimmer. Instead of these teeth, Dunkleosteus possessed two pairs of sharp bony plates, which formed a beak-like structure. Again, Dunkleosteus, together with most other placoderms, may have also been the first vertebrates to internalize the egg fertilization as seen in modern sharks. So what they did was, instead of laying eggs, they used to have eggs and they used to have their legs inside their body, just like sharks, and they used to give birth to live young, which is called ovoviviparous. Ovo for egg and vivi for giving birth to live young. Well, next I'll skip the lamprey for the moment and go to the Electrophorus. So Electrophorus, or the electric eel, scientific name Electrophorus electricus, is a South American electric fish. Until 2019, it was classified as the only species in its genus. Despite its name, it is not actually an eel, but rather a knife fish, which is more closely related to the catfish. Yeah, you can see that it has similarities to the catfish in the way its head looks like. The electric eel has an elongated cylindrical body, typically growing to about 2 meters in length and 20 kilos in weight. The electric eel has 3 pairs of abdominal organs that produce electricity: the main organ, the hunter's organ, and the sachs organ. These organs make up 4/5 of its body and give the electric eel the ability to generate two types of electric organ discharges: low voltage and high voltage. These organs are made of electrocytes lined up so a current of iron can flow through them, and stacked so each one adds to a potential difference. When the eel finds its prey, the brain sends a signal through the nervous system to the electrocytes. This opens the ion channels, allowing sodium to flow through, reversing the polarity momentarily. By causing a sudden difference in electric potential, it generates an electric current in a manner similar to a battery, in which stacked plates each produce an electric potential difference. These electric eels are also capable of controlling their prey's nervous systems with their electrical abilities. By controlling their victim's nervous system and muscles via electric pulses, they can keep prey from escaping or force it to move so they can locate its position. Exactly what this Electrophorus does in the game. When it gives you the electric shock, it kind of stuns you, exactly like in real life. Now, electric eels, they can make a shock up to 860 volts and up to 1 ampere of current, which is huge, by the way. This level of current is reportedly enough to produce a brief and painful numbing shock likened to a stun gun discharge. It's like, getting hit by a taser, which due to the voltage can be felt for some distance from the fish. This is the common risk for aquarium caretakers and biologists attempting to handle or examine electric eels. Yeah. So, electric eels use electricity in multiple ways. Low voltages are used to sense the surrounding environment. High voltages are used to detect prey and separately stun them. Pairs of high voltage pulses separated by 2 milliseconds are used to detect and locate prey by causing them to twitch involuntarily. The electric eel can sense this movement. A string of high voltage pulses at up to 400 per second are then used to attack and stun or paralyze the target, at which point the electric eel applies a suction feeding bite. I have actually seen a video of an electric eel in the South American Amazon River, in which caiman crocodile, caiman is a type of crocodile, same family. So a caiman accidentally came close to an electric eel, and the electric eel gave it a shock so powerful that the caiman crocodile not only got stunned, eventually died from the electric shock. It was just shaking and eventually died off. That is how dangerous these electric eels actually are. Okay, now let's come to the lamprey. Lampreys are an ancient extant lineage of jawless fish. The adult lamprey may be characterized by a toothed funnel-like sucking mouth. Let me show you that part. This thing. Yeah, it's very accurate. It's very accurate actually. Ark's depiction is really very accurate. There are about 38 known extant species of lampreys and 5 known extinct species. Parasitic carnivorous species are the most well known and feed by boring into the flesh of other fishes to suck their blood. But only 18 species of lampreys engage in this micropredatory lifestyle. The other lampreys are all non-carnivorous forms and are belonging to freshwater species. Adults of the non-carnivorous species do not feed. They live off of reserves acquired as larvae, which they obtain through filter feeding. So some of the lampreys can actually be harmless. These adults superficially resemble eels in that they have scaleless elongated bodies and can range from 13 cm to 100 cm, which is like 1 meter in length. Sea lampreys have become a major pest in North American Great Lakes. It is generally believed that they have gained access to the lakes via canals during the early 20th century. They are considered an invasive species, having no natural enemies in the lakes, and prey on many species of commercial value such as lake trout. Okay, now I'll skip the small guys and head directly to the biggest bull in the museum, the lead Cyctis. Now, lead Cyctis is a giant member of the Pachycormidae, an extinct group of Mesozoic ray fin fish that lived in the oceans of the Middle Jurassic period. Lead Cyctis means Leeds fish, after the British collector Alfred Nicholson Leeds, who found a lot of its fossils in the 19th century. So, Lead Cyctis fossils have been found in England, France, Germany and Chile. Lead Cyctis fossils have been difficult to interpret because the skeletons were not completely made of bone. Large parts consisted of cartilage that did not fossilize. This is the same reason why it is difficult to predict the size of ancient sharks, because sharks are made of cartilage and they don't fossilize. As the vertebrae are among the parts that have not been preserved, it is hard to determine the total body length. So, estimates have varied significantly. At the beginning of the 20th century, a length of 9 meters or 30 feet was seen as plausible, but by its end, Lead Cyctis was sometimes claimed to have been over 30 meters long. Modern research has lowered this to about 16 meters or 50 feet for the largest individuals. Like the largest fish today, like the whale sharks and basking sharks, Lead Cyctis problematicus derived its nutrition as a suspension feeder, using an array of specialized gill rakers lining its gill basket to extract zooplankton and small animals from the water, passing through its mouth here and across its gills. It is less clear whether also phytoplankton algae were part of its diet. Okay, now we come to the manta. Okay, so manta rays are large rays belonging to the genus Mobula, formerly its own genus Manta. The larger species, Manta birostris, reaches 7 meters in width, while the smaller Manta, or rather say it's better to say Mobula, while the smaller Mobula alfredi reaches 5.5 meters. Both have triangular pectoral fins, these fins, and these things. These are called horn-shaped cephalic fins and large forward-facing mouths. Mantas are found in warm, temperate, subtropical and tropical waters. Their tails lack skeletal support and are shorter than their disc-like bodies. So, this ones. The largest mantas can reach around 1350 kilos or around 3000 pounds. Their skin is covered in mucus which protects it from infection. Okay, something for you mutation fanatics. So you guys like mutation, so you will like to hear this. So a pink colored manta ray has been observed in Australia's Great Barrier Reef, and scientists believe this could be due to a genetic mutation. The fish spotted near Lady Elliot Island is the world's only known pink manta ray. Yeah, so those funny colors actually happen in real world also. So manta rays are filter feeders as well as macro predators. On the surface, they consume large quantities of zooplankton in the form of shrimp, krill, and planktonic crabs. In the deeper depths, mantas consume small to medium-sized fish. When foraging, it slowly swims around its prey, herding it into a tight ball like this, moving like this, and slowly making the circle smaller, and then speeds through the bunched organisms with a wide open mouth. Mantas are themselves preyed upon by large sharks and by killer whales. They may also be bitten by cookie cutter sharks and harbor parasitic copepods. Another interesting thing about mantas is mantas visit cleaning stations on coral reefs for the removal of external parasites. The ray adopts a near stationary position close to the coral surface for several minutes while the cleaner fish consume the attached organisms. This is a very nice example of symbiotic relationship in which the mantas get clean and those cleaner fish get some nutrition from them. Next we come to the highlight of all the fishes on Ark, the Megalodon. So Megalodon, or Carcaroclis megalodon, meaning big tooth, is an extinct species of shark that lived approximately 23 to 3.6 million years ago during the early Miocene to the Pliocene epoch. It was formerly thought to be a member of the family Lamnidae and a close relative of the great white shark, which is Carcharodon carcharias. However, it is now classified into the extinct family Otodontidae, which diverged from the great white shark during the early Cretaceous. While regarded as one of the largest and most powerful predators to have ever lived, Megalodon is known from fragmentary remains, and its appearance and maximum size are uncertain. Scientists differ on whether it would have more closely resembled a stockier version of the great white shark, the basking shark, or the sand tiger shark. Most estimates of Megalodon's size extrapolate from its teeth, these teeth. And what they say is that this estimates extrapolated from teeth say that estimates of up to 18 meters and average length estimates of 10.5 meters. So, it's between 10.5 and 18 meters. So, if at 18 meters, it should be slightly bigger than even a Mosasaurus. These estimates suggest their large jaws could exert a bite force. Now, let me say this again. Estimates suggest that their large jaws could exert a bite force of up to 110,000 to 180,000 newtons. I mean, this is astronomical. astronomical, like a saltwater crocodile, which has possibly the highest bite force in the current uh, ecosystem right now, has a bite force that would be, I think, less than 1/10 of this. I think the saltwater's bite force is around 12,000 or 13,000 newtons, and these guys have a bite force of like what, 110,000 to 180,000 newtons. Their teeth were thick and robust, built for grabbing prey and breaking bone. So you know that saltwater crocodiles from India and Australia are so powerful, their jaws are so powerful that they can, with one bite, break the bone of any animal. Doesn't matter, even they would be able to break the bone of any bison, buffalo, or even an elephant. And these sharks have a bite force that is, 10 to 15 times more than that. So unbelievable. Okay. So it probably targeted large prey such as whales, seals, and sea turtles. Juveniles inhabited warm coastal waters and fed on fish and small whales. Yeah, even the juveniles could feed on whales. Imagine that. Unlike the great white shark, which attacks prey from the soft underside, Megalodon probably used its strong jaws to break through the chest cavity and puncture the heart and lungs of its prey. A direct frontal attack. The animal faced competition from whale-eating cetaceans such as Leviathan and other macroraptorial sperm whales, and possibly smaller versions of ancestral killer whales. As the shark preferred warmer waters, it is thought that oceanic cooling associated with the onset of the ice ages, coupled with the lowering of sea levels and resulting loss of suitable nursery areas, may have contributed to its decline. The extinction of the shark appeared to affect other animals. For example, the size of baleen whales increased significantly after the shark had disappeared. Mature male megalodons may have had a body mass of 12.6 to 33.9 metric tons, and mature females may have been as large as 27.4 to 59.4 metric tons, assuming that males could range in length from 10.5 to 14.3 meters and females between 13.3 and 17 meters. So think about this. A T-Rex has a weight of around 8 to maximum 10 tons. A Spinosaurus could at best be around 7 to 11 tons. And these guys are over 3 to even 5 times as much of that. Imagine that. Okay, so a 2015 study linking shark size and typical swimming speed estimated that megalodons would have typically swim at 18 kilometers per hour, assuming that its body mass was typically 48 metric tons. So they were not that fast swimmers, but they were rather powerful. They were kind of, think of it like a brute. Next we come to the Piranha, whose model has not completely, okay, it has loaded now. Piranha actually is the Mega Piranha. Okay, so Mega Piranha is an extinct Cerasalmid Caracine fish from the late Miocene, that is 8 to 10 million years ago, of Argentina, described in 2009. The type species is Megapiranha paranensis. It is thought to have been about 71 centimeters in length and 10 kilograms in weight. The holotype consists only of premaxillae and a zigzag tooth row. Again, another problem with fishes, you don't get the complete fossil. So it only has the premaxillae and the zigzag tooth, that is this small front part. The rest of its body is unknown. This dentition is reminiscent of both the double row seen in Pacus, which is a piranha related like fish, and the single row seen in teeth of modern piranhas, suggesting that the Mega Piranha is a transitional form between current piranhas as well as the Pacus. Its bite force is estimated between 1240 to 4749 newtons. Depending on the Megapiranha's weight, that force would range from 9 to 50 times its weight. Just a trivia, pound for pound, that's like if a supermodel had the bite of a T-Rex. Yeah, seriously. Lastly, we come to the saber-tooth salmon. Now, the saber-tooth salmon, or Oncorhynchus rastrosus, or synonym Smilodonyctis rastrosus, also known as the saber-tooth salmon, is an extinct species of salmon that lived along the Pacific coast of North America, first appearing in the late Miocene in California, then dying out sometime during the early Pliocene. Adults grew to be about 2.7 meters in length and are believed to have been anadromous, that is migratory, like their living relatives. So what they do is these fishes which are anadromous, they will migrate to they will do a temporary migration to warmer coastal or even river waters and lay their eggs, and their small children will hatch in that shallow part, which will be acting like a nursery, and then those children will migrate over to the deeper oceans when they become old enough. Yeah, just like any salmon. Besides being the largest member of the Pacific salmon genus Oncorhynchus, members of the species had a pair of small fangs protruding from the tip of the snout. These first two things, thus explaining the common name and its synonyms. Okay, so that's the entirety of the fish exhibit. I hope you got to learn a lot from my lecture. So I've been a paleontology nerd from a very early age, so I love giving these lectures. So in the next video, I'll be taking a look at all the invertebrates, that is all the insects and other cephalopods and other stuff that you will find on the seas. So till then, thank you for watching and stay tuned for more.